Wood. I mean, we use it for everything, right? We build our homes with it, we craft our furniture. We just love its natural beauty. But here's the thing. Beneath that sturdy-looking surface, there's often a secret battle going on against some silent, really relentless enemies. Okay, so let's dive into this hidden world and figure out how to protect one of our most important materials.
Just look at this contrast. On the one hand, you've got this beautiful, strong, vibrant wood, exactly what we want. And on the other, total, complete devastation. So what on earth happens to get from point A to point B? What is secretly attacking our wood? And way more importantly, how do we stop it?
All right, so the threats to wood, they really fall into two main camps. You've got the living organisms, we call those biotic agents, and then you have environmental forces, or abiotic agents. Let's pull the masks off these culprits one by one.
First up, the living invaders. And we're talking about the whole spectrum here, from microscopic fungi you can't even see, all the way up to highly organized, multi-legged armies. And they all have one thing in common. They are literally eating our wood from the inside out.
Let's start small, really small. Fungi are microscopic organisms that basically see wood as an all-you-can-eat buffet. But they're a little bit picky. For fungi to really get going, they need a very specific recipe. The wood's moisture has to be somewhere between 18 and 55%, and they like it nice and cozy, between 18 and 28 degrees Celsius. If you give them those conditions, the feast begins. And different types of fungi have different tastes. You've got brown rot, which goes after the cellulose. You can think of that as the flesh of the wood. It leaves behind these brittle, reddish-brown cubes. Then there's white rot, which prefers the lignin. That's more like the wood's bones or skeleton. That leaves the wood feeling soft and looking whitish. So two different attacks, but the same disastrous result.
Now, not all fungi are out for total structural annihilation. Take a look at this. These are chromogenic fungi, and the most famous one is blue stain. It actually feeds on the sugars inside the wood, not the important structural parts. So while it creates this really distinct bluish stain, it's mostly a cosmetic issue. The wood is still strong. Okay, time to play detective for a second. You see this in an old chair or a floorboard, this weird pattern of tiny, almost perfectly round holes. What in the world could be doing that? Well, the answer isn't what's on the surface.
It's these guys. The real culprits are the larvae of insects, like the woodworm, which is actually a type of beetle. Here's how it works. The adult beetle lays its eggs in the wood. The larvae hatch and then spend years, literally years, tunneling around inside, munching on cellulose. Those little holes we saw, those are the exit doors. That's what the adult makes when it finally emerges. All the real damage was already done long before you ever saw a single hole.
But when we talk about insect threats, there is one name that stands head and shoulders above the rest in pure destructive power: the social insects, specifically termites. And this isn't just a few grubs minding their own business. No, this is a highly organized army. And this is exactly why they're so terrifyingly effective. Termites attack from the inside, and they leave the outer layer of the wood completely intact, like a thin veneer. You won't see any exit holes, there's no sawdust, nothing. They work in the dark, they need high humidity, and by the time you actually realize they're in your house, a colony of thousands or millions might have already caused catastrophic damage.
But you know, it's not just the living things that are after our wood. The environment itself is a relentless opponent. And let's look at one of its most powerful weapons: everyday sunlight, and the two types of radiation it brings to the fight.
Have you ever wondered why wood that's left outside turns that classic silvery gray color? Well, the culprit is ultraviolet radiation, or UV rays. The UV light actually breaks down the lignin in the wood's surface cells. Then, when it rains, that degraded lignin just gets washed away, leaving behind that weathered gray look we all recognize. And the sun's other big weapon is infrared radiation, or IR. We feel this as heat. IR rays cause the surface of the wood to get really hot and dry out way faster than the inside of the wood. This creates a huge amount of internal stress, and eventually the wood has to release that tension. And it does so by forming these deep, ugly cracks and splits.
So, now we've met the enemies. How in the world do we fight back? Well, modern wood protection isn't about just grabbing the strongest chemical and blasting everything with it. No, it's a much smarter approach. It's about figuring out the specific level of risk based on exactly where and how that piece of wood is going to be used. And to do this, the entire industry uses a standardized system of 5 risk classes. It's really just a simple scale that helps you figure out the threat level. It goes all the way from a super safe indoor spot to the absolute most hazardous conditions you can imagine.
For example, here's a perfect case of Risk Class 1. This cabinet is indoors, it's in a dry house, it's completely protected from rain and sun. The chance of it being attacked by fungi or insects is practically 0. Now let's jump up the scale a bit to Risk Class 3. These shutters are outside. They're getting blasted by UV rays and soaked by rain. However, and this is a big however, they are not touching the ground, which means they have a chance to dry out. This is a much higher risk than the cabinet for sure, but it's still not the worst-case scenario.
And here we have it, the final boss, Risk Class 5. These are pilings for a pier, and they are in permanent, constant contact with salt water. Salt water is an incredibly aggressive environment. This situation demands the absolute highest level of protection you can get, period.
So knowing the risk class is absolutely the crucial first step. The next step is to choose the right armor. You need the correct protective treatment that's been specifically designed to handle that exact level of threat. And this chart makes it really simple. For Risk Class 1, you might not need any treatment at all, or maybe just a bit of varnish for looks. For Class 2, a simple surface stain is probably enough. But as you climb that ladder to Risk 3 and 4, we start moving into much more serious industrial methods that force the preservative deep inside the wood. Okay, let's make this really practical. Imagine you're building a new deck. The support posts, the ones holding the whole thing up, are going to be set in direct contact with the ground. That puts them squarely, no question, in Risk Class 4. So what's the right solution? The answer is this machine, a pressure autoclave. Now, this is not just a coat of paint. The wood gets placed in a sealed chamber. They create a vacuum, and then they flood it with a protective solution, usually containing copper salts, and force it deep into the wood's fibers using intense pressure. You know that signature green tint you see on lumber at the hardware store? That's the sign of this deep, powerful protection. So we have the knowledge, and we clearly have the technology. We can make wood last for an incredibly long time. So what's the trade-off here? Let's talk about the real investment in longevity. Okay, and here's maybe the most crucial takeaway of all of this. Proper treatment is a tiny investment that gives you a massive return. Adding just 20 to 30% to the initial price of the wood can extend its life from just a few years to more than half a century. Honestly, it's one of the best investments you can possibly make in your home. And this is not a new idea. Just look at this incredible wooden stave church in Norway. It was built centuries ago, and it's still standing strong against everything the elements can throw at it. Humans have known the basic principles of protecting wood for a long, long time, combining smart design with the best preservation techniques available. We have the ability right now to choose materials that will last for generations, which would reduce waste and the endless need for repairs and replacements. So, knowing what we now know about wood's enemies and its defenses, the real question isn't whether we can build to last, it's whether we're willing to make that choice, to actually build for the future.